Okay, in order to add or subtract matrices, the two matrices that you're trying to add or subtract have to have the same dimensions. So dimensions is m times n, where m is the number of rows and n is the number of columns. And you'll see this is a 2 by 2 matrix and this is a 2 by 2 matrix. So I could add these two. And when you're adding matrices, oh goodness, it's easy. It's as simple as adding the corresponding numbers in each matrix. Now, corresponding means in the same position. So this guy right here, A11, corresponds with this guy right here, B11. And A22, which is row 2, column 2, by the way, corresponds with B22, which is row 2, column 2. Notice, this is row 2, column 1, row 2, column 1. Those are corresponding elements. So that's all we've got to do. So if you want to do down here at the bottom of the page, C plus D, notice, what are the dimensions of this matrix?
3 by 2.
2 by 3, because it's rows by columns. So this is actually a 2 by 3. They are the same, so we can add them. If they are not the same, you cannot add them. So it's as simple as this. See the 3 and the 1? 4. All right? See 2 and 4 corresponding? 6. 4 and 3 corresponding? 7. Negative 1 and negative 2? Negative 3. 4 and 2? 6. 0 and 4? 4. How was that?
Tricky.
Tricky. All right. How about C minus D? This is just as simple. You're going to take these values minus these values. So I've got 3 minus 1 gives me 2. 2 minus 4 gives me negative 2. 4 minus 3 gives me 1. Negative 1 minus negative 2 gives me 1. 4 minus 2 gives me 2. And 0 minus 4 gives me negative 4. So there's subtraction. There's adding and subtraction. You've got it. Okay, the next thing that we're going to do is learn how to solve a matrix equation. And so here's what I have as a matrix equation. I have this capital letter A is in place of a matrix. So in other words, this matrix plus some unknown matrix equals this matrix, and we have to figure out what this is. Okay? And that's what we're going to go about doing. Now, in order to do this, I want to do an example where we have real-world data, because that's what goes in matrices is real-world data. So let's go down here further on the page. And this matrix is for wins and losses, okay? So the first table shows the teams with the 4 best records halfway through their season. Here's the 4 teams, here's their wins and losses, okay? The second table shows the full season records for the same 4 teams. This is the first half, this is full season. Which team had the best record during the second half of the season? In order to answer that, we need to know what the records were for the second half of the season, right? So if I know the first half and I add the unknown second half, I will get the whole season, right? First half plus second half equals season. Well, here is a matrix representing the wins and the losses of these 4 teams. And here's the wins and the losses for the season. So if I can find out what this matrix is, this will represent my second half of the season. So let's put a little arrow down here, and this is going to be records for the second half of the season. Okay? And here's how we go about solving for this. You remember having a lovely little equation like this? 2 plus x equals 5, right? And what did you do to solve for x? Subtract 2. We're going to do the same thing. We're going to subtract this matrix from both sides. All right? So I am going to subtract and I'm going to do it on this side as well. Okay, so what you want to do at this point is get your calculator out and see if we can figure this out. So x equals, all right, 23, 18, wow. All right, is this what you guys got? Okay. So which team had the best record for the second half of the season? Which one of these is the best? The second one, which is team 2. So our answer, team 2. Because these are wins, these are losses. Pretty cool? That's how you solve a matrix equation. All right, let's flip the page. Okay, we got to go through some different vocabulary related to matrices. A zero matrix. A zero matrix, which you can identify as O or O m times n, means that all the elements in the matrix are 0. They just all are 0. This is a zero matrix right here. Let's put a little arrow. Zero matrix. All right, and obviously this, when you add it to any matrix, you get that same matrix, right? Because you're just adding 0 to all of the elements. So 1, 2, 5, and -7. That's a zero matrix. Now, there's another thing called an opposite matrix, and opposite matrices are like these. They have the same elements, but different signs. So 2 and -2, 8 and -8, -3, +3, 0 and 0. So these are opposite matrices. What do you think you will get if you add these? A zero matrix. That's exactly correct. All right, we have some properties of matrices that you should probably be aware of. Okay? First of all, with addition, there is the commutative property of addition. Matrix A plus matrix B is the same as matrix B plus matrix A. I know this seems like, okay, well, that's really basic. Why would I point that out? Because the same is not true of multiplication. It is true of addition, though. So it doesn't matter what order you add them in. It also doesn't matter which ones you group together first. So there's the associative property of adding matrices. Remember identity property? What can you do to something and get itself? well, in this case, you can add a zero matrix to it, and you get itself. And the additive inverse property says that if you take any matrix and its opposite, you will get a zero matrix. All right? I think maybe this is our last example at the bottom of the page here. We're going to solve for some values, some variable values that happen to be in matrices. Now, these two matrices are equal, right? Because I have an equal sign between them. Notice, a 9 in both places, right? So 3x plus 1 must be equal to 16. Is that a fair assumption then? So 3x plus 1 must be equal to 16, which means 3x is 15 and x is 5. Cool? 2y minus 1 must be equal to negative 5. Add 1 to both sides. 2y equals negative 4. Y equals negative 2. And these last two are already the same exact thing. So that's another thing that you can do with your matrices, all of which you will be doing in your homework for this evening. All right, one last example to go through. You can make some equations out of a matrix equation like this. For example, z minus 10 equals 2, right? So z equals 12. Negative 3 minus negative 4 is 1, yes. 3x plus x equals 8. Gives us 4x equals 8, which means x equals 2. And lastly, 0 plus 2y plus 6 equals 4y plus 12. Okay, subtract 2y on both sides, and I have 2y plus 12 equals 6. Subtract 12 on both sides, negative 6 equals 2y. Y equals negative 3.